A raw pod is just one running copy. If it disappears, users feel it immediately. That is the first trap. A pod can die without replacing itself. Production needs a promise, not a disposable object. The payoff is desired state. Kubernetes compares what you asked for with what is running, then controllers close the gap. The confusion usually starts when people treat deployment, ReplicaSet, and pod as interchangeable. They are not. A pod runs the workload. A ReplicaSet keeps the number of pods correct. A deployment manages version changes and rollout intent. A deployment is the object you normally edit for a stateless application. It captures the rollout intent. Which version should run, how many replicas are desired, and how the pod template should look. A replica set is more focused. It watches pods that match its selector and keeps the count aligned. If the desired count is 3 and only 2 matching pods are running, the replica set creates another one. Pods are the running copies. They hold the actual containers, network identity, and lifecycle state. They are the things that crash, restart, get rescheduled, and receive traffic through services. The owner chain is the important picture. The deployment owns the replica set. The replica set owns the pods. The control plane uses that chain to turn a high-level application change into the right running copies. A pod is a runtime boundary for one application instance. It can contain one or more tightly coupled containers, and those containers share networking and some attached resources. For most beginner workloads, think of one pod as one copy of the app. Controllers do not manage pods by guessing names. They use labels and selectors. If a pod matches the selector, it belongs in the controller's view of the world. If the label does not match, the controller ignores it. A pod is not something you nurse back to health like a pet server. In normal Kubernetes operation, a broken pod is replaced with a new one from the template. That replacement may have a new name, new IP, and new lifecycle history. That is why production systems should not depend on a specific pod name or pod IP as the application contract. Pods change. The stable identity belongs above them through services, deployments, and the declared application model. A replica set has 2 key ideas, a selector and a pod template. The selector tells it which pods count. The template tells it what to create when more matching pods are needed. Replica set behavior is a reconciliation loop. It observes the current pods, compares that number to the desired replica count, and takes action until they match. It is simple, but it is the reason the app keeps the right number of copies. When you scale an application, you are really changing desired replicas. The controller does the work of creating or removing pods to match the new number. The user-facing goal is more capacity without manually managing each copy. In a deployment-based app, you usually do not edit the replica set directly. The deployment owns it. Manual changes at the replica set layer can be confusing or overwritten by the higher-level controller. A deployment is what turns a version change into a controlled rollout. Instead of deleting old pods and hoping, you update the deployment's template and strategy. Kubernetes then coordinates the transition. When the pod template changes, the deployment creates a new replica set for that new template. The old replica set is not the same as the new one, because they represent different desired pod versions. A rolling update shifts the running copies gradually. New pods come up, become ready, and old pods are removed. The point is to change the application without a big bang outage. If the new version is bad, the deployment can roll back to a previous template. That is one reason the deployment layer matters. It keeps rollout history and gives operators a safer way to recover. In production, rollout safety depends on readiness. A new pod should not receive traffic just because it exists. It should receive traffic after it proves it is ready to serve. Replica count is not magic capacity. If the cluster does not have CPU, memory, or scheduling room, extra pods may stay pending. Good teams connect scaling decisions to resource limits and node capacity. When something goes wrong, do not inspect only one layer. Check the deployment status, the ReplicaSet count, pod readiness, and events together. The failure usually becomes obvious when you follow the chain. The senior habit is to change the declared application object, not patch random running pods. Controlled deployment changes give you review, rollout behavior, observability, and a rollback path. If you keep only one model, keep this one. Pod runs the app. ReplicaSet keeps the count. Deployment manages rollout. That simple split removes most beginner confusion. For normal, stateless applications, start with a deployment. It gives you replica management through ReplicaSets, running pods underneath, and a clean operational object for rollout and recovery. When debugging, start from intent and walk downward. What did the deployment ask for? What replica set was created? How many pods are ready? What do events say? That path is faster than guessing at the bottom. The professional question is simple. Which layer owns the change you are making? If it is version, rollout, or rollback, think deployment. If it is count reconciliation, think replica set. If it is runtime evidence, inspect the pod.